It's one of the great mysteries of science. A mystery that, if solved, will force us to rethink our place in the universe. Is life on Earth unique? Or is it spread throughout the cosmos? If we share the stars with aliens, why haven't we heard from them? Or are we truly alone? Space, time, life itself. The secrets of the cosmos lie through the wormhole. We've all done it. Stared into the night sky, gazed at the vast canopy of stars and wondered what or who is out there. Is there other life in the universe? Maybe on a planet like ours with water and air? Or on some other kind of planet or moon, supporting an alien form of life? As a young boy growing up in the Mississippi Delta, I'd sit on the porch in the evening with my family, and we'd talk about things. When it was cloudy, it was very dark, pitch black. We would think we were all alone, and then sometimes people would just appear out of the darkness.
Will you see coming, Morris?
It's Devin and Travis.
Hi, boys.
Could our universe be just as deceiving? Might other sentient life forms just appear out of the seeming darkness of space? There are more stars in the universe than all the grains of sand on every beach on Earth, and countless planets orbit those stars. So it would be arrogant to think that we are the only creatures in the cosmos. I think it's easy to imagine life on other worlds, and I'm not alone. A whole category of scientists investigate alien life. They are called astrobiologists. Lynn Rothschild of the NASA Ames Research Center is one of them.
I am so lucky that I have a job that is so incredibly fascinating. Because to me, it's impossible not to be fascinated with the potential for life. To me, looking for the bizarre, the extreme, the exceptions, and some of it's here on Earth, but there may even be some of it elsewhere. And I mean, that's the sort of thing that just absolutely blows your mind.
We form theories about alien life by first looking at life on Earth. Our planet is filled with an incredible diversity of creatures, uniquely tailored to their environments by billions of years of evolution.
A normal condition for life, what we see, is all lovely, and it's just sort of these medium temperatures and so on, but it only describes a very tiny slice of where life can actually survive. We need to have liquid water, but they're organisms that can beat the odds and live above the boiling temperature of water and below the freezing temperature. We have to be in a certain environment that's not too acidic and not too basic, and yet there are organisms that can live down incredibly acidic conditions.
Life on Earth can survive in extreme environments, but can life survive on other worlds? It's a mystery set in space, and that makes it tough to investigate because the human race has barely left Earth. Searching for clues is incredibly difficult. Fortunately, sometimes the clues come to us. In 1969, a 220-pound meteorite crashed into Murchison, Australia. The Murchison meteorite was more than just a piece of rock floating through space. It was a doorway to alien life. A piece of the meteorite is kept here at the California Academy of Sciences.
The reason this is so exciting to scientists is that it's as old as the solar system, and yet we found that it contains the building blocks of life, things like amino acids and other sorts of chemicals that we use to make our own bodies and all life on Earth. So what it shows is that these building blocks were around in our solar system before life arose on the Earth.
Life may have come to Earth in a meteorite like this, and life similar to ours may be spread through the universe in the same way, as meteorites act like seeds, raining down the ingredients for life on fertile planets. So what does this mean for our hunt for ET? For one thing, If the common elements of life as we know it are spread throughout the universe, then life on other planets might be similar to life on Earth.
If we look at enough sci-fi movies, there are all sorts of weird and wonderful aliens out there. But what we're really interested in is what these organisms are built from. And if you look at life on Earth, we're all built on a form of carbon chemistry called organic chemistry. And this seems to be the language of life. If you look out into the interstellar medium, the same compounds are there as on Earth. If you look at what we're made of secondarily, it's water. There's water all over the universe. So in terms of our biochemistry, life everywhere, I think, would be very similar to Earth in terms of its biochemistry.
But alien life would not necessarily look like human life. Life evolves to suit its environment.
One of the big things that would affect what life looks like on another planet, particularly if you're starting to look at large life, macroscopic life like us, is what the gravity's like. Now on Earth, we've all evolved under 1G, one gravity. But if we evolved on a planet with 2G or 5G, for example, we would have to have correspondingly thicker legs, we'd have to have much stronger limbs to hold up our weight, and maybe at some point we'd be pushed so we were basically flat in the ground because we couldn't hold up any weight at all. But conversely, if we had evolved on a planet that, say, had half G, maybe we'd be tall and thin and avatar-like, creatures, and not the way we are today. So gravity is something we don't tend to think about, but that really is one of the things that shapes life.
If there are aliens out there, finding them will be incredibly difficult. Astrobiologists are like detectives that can't get near the crime scene. They're limited by our technology, which so far can barely send probes to nearby planets. These probes tell us that Earth harbors the only currently known sentient life in our solar system, which doesn't mean there isn't any life out there. NASA is optimistic about someday finding simple forms of life on one or more of our neighbors. Microbes may live in the Martian soil or float in the clouds of Venus. Strange creatures could swim in the icy waters of Saturn's moons. If we find alien microbes outside the Earth, or even Earth microbes thriving on other worlds, it greatly raises the odds that life is scattered across the universe. E.T. probably isn't in our neighborhood, but the universe is unimaginably large. He, she, or it may be out there somewhere. So around the world, science detectives have sent out an all-points bulletin for extraterrestrial life. They're listening to the stars, staking out possible lairs, putting together composite sketches, and looking for clues it may have left behind. The hunt is on. And now we're discovering the incredible truth. We don't have proof that we share the universe with other intelligent species, but many scientists believe that they are out there, proof or not. Perhaps extraterrestrials are watching us right now. Maybe they just sent us a message. Or maybe they have no idea that we're here, and they're talking among themselves. We'll never know the truth unless we listen. For half a century, the SETI project, the search for extraterrestrial intelligence, has done just that. SETI combs the sky with radio telescopes, hoping to hear alien transmissions. They're trying to wiretap ET, but they don't have his phone number. So, much as the CIA hunts for terrorist chatter, SETI tries to listen to everything out there. It's a daunting task. For starters, how can we tell the difference between a natural signal from the stars and an intelligent signal sent by strange alien beings? Dr. Jill Tarter is SETI's chief alien hunter.
If you'd like to listen to the cosmos, take an old-fashioned radio like this, an analog radio, and tune the radio between stations. And you hear that hiss? About 10% of that noise is actually coming from the cosmos. That's synchrotron radiation from the Milky Way galaxy.
SETI has combed the cosmic radio dial for 50 years. Most days it's quiet out there, but once in a great while, something exciting happens. In 1977, a SETI astronomer picked up a signal from the constellation Sagittarius. It lasted 72 seconds, the full duration the radio telescope was pointed at it. Going through the data, the scientists circled the signal and wrote, "Wow." The signal looked like the kind of engineered pulse that we expect will come from an alien civilization. The WOW signal was a one-time event. Astronomers have returned to that part of space, looking for the signal, hoping for a repeat, but always coming away disappointed. To this day, there is still no explanation for what happened. In 1997, 20 years after the WOW signal, SETI detected another signal from space, and Jill Tarter was there to witness it. At 6 o'clock in the morning at an observatory in West Virginia, Tarter and her team heard a mysterious sound coming from the Cetus constellation.
The signal showed up early one morning at the Green Bank National Radio Astronomy Observatory when we were using the 140-foot telescope there. I was actually at the telescope. We detected a signal, and it was clearly a manufactured signal. It wasn't just one tone on the radio dial. It was like a cone. Many different signals, all narrow, all separated by the same amount of frequency. Mother Nature wasn't doing that.
After years and years of listening, years and years of silence, Tarter wondered, is this it?
I was incredibly excited, and I was scheduled to finish up my observing shift in West Virginia at 8 o'clock and get on a plane and come home. When this started at 6 o'clock in the morning, I certainly wasn't going to get on any plane and leave the signal behind.
Tarter initiated a series of tests to verify the signal and find out if it was natural, man-made, or alien-made.
We moved the telescope off the star we were pointing on. The signal went away. We moved it back on the star. The signal was there. I thought, oh, I wonder if any of our other observations have seen that same kind of signal. But I was so excited that when I looked at the output, I didn't see that exactly what I was looking for was there. We had, at previous occasions, detected this signal with this frequency spacing. It turned out that it was a signal that was coming not from the direction that we were looking in, but a signal that was coming in our side lobes.
Tarter and her colleagues had made a mistake. The signal they detected was not alien. It came from a man-made space probe orbiting the sun called SOHO. SETI learned that to communicate in the cosmos it needed better technology. And now they're getting it. In Northern California, SETI is building hundreds of new devices to wiretap ET.
We're here in Northern California at the Hat Creek Radio Observatory. Right now, what we have is the Allen Telescope Array, an innovative new way to build a radio telescope, a large telescope out of small pieces.
By linking together a large number of small telescopes, the ATA gives astronomers a wide field of view, a radial picture 10 times the size of the full moon.
Today, we've got 42 of these dishes that are 20 feet across, and we're looking forward to expanding it till there are 350 of these small dishes. It may be just the right tool, finally.
The ATA gives SETI the ability to observe many more channels on the cosmic radio dial.
Now, because of technology, we simultaneously observe hundreds of millions of channels. And I look forward to the future when I can do billions of channels all at once. So technology has enabled the search on a scale that might finally be big enough to be able to detect something.
SETI scientists have wiretapped the stars for 50 years, but there's still no sign of extraterrestrial life. The great silence remains. And maybe that's not surprising.
SETI really is a needle in a haystack search without any guarantee that there's a needle out there.
Professor Paul Davies is a physicist and a SETI affiliate, but he's something of a heretic within the group.
The traditional approach to SETI is to scan the skies with a radio telescope in the hope of picking up a message from some alien civilization that's being deliberately beamed towards Earth. I don't think that's credible, and here's why. One of the big problems in this whole SETI business is the vast scale of things. The universe is really, really big. By human standards, it's just stupendously big. Imagine we get the smallest speck of dirt from the desert floor, and that represents the size of our solar system, right out to the orbit of Pluto. And then ask, how big is our galaxy? How far would you have to go to get to the far side of the Milky Way? And the answer is all the way to those hills right in the distance over there. And if you ask, how far do you have to go to get to the edge of the observable universe? Well, you'd need to go right out to the orbit of Mars.
It's often said that because our radio and television signals have beamed into space for 80 years now, aliens should have figured out that we're here and have sent us a message. But this argument overlooks a basic law of physics.
Another way of thinking about this is in terms of the speed of light, which travels at 186,000 miles every second. It takes light about 100,000 years to cross our galaxy, and it takes 13.7 billion years for it to cross the universe. Our first radio signals, which leaked out into space about 100 years ago, have gone about that far by comparison. Suppose there's a civilization 1,000 light years away, and that's actually pretty close by even SETI optimist standards. Well, they don't see Earth as it is today. They see it as it was 1,000 years ago. There were no radio telescopes here then, so it would make no sense for them to start sending messages to us until they knew that we were on the air. And they're not going to know we're on the air until our first radio messages reach them, and that's going to be in another 900 years.
Listening for signals from the stars is a long shot. So how can we do a better job of tracking down extraterrestrial life? As SETI monitors its cosmic wiretaps, another set of science detectives follow radical new leads. Leads that may take us right to ET's doorstep. Listening for signals from the stars is one way to search for other intelligent life in the universe. But there are other ways we can find out where ET lives. Astronomer Jeff Marcy hunts the sky for planets that could sustain alien life. For many years, people thought he might be crazy.
When I would tell other scientists that I was hunting for planets around other stars, they would look down at their shoes, embarrassed for me. You might as well be looking for fairies or for alien civilizations in the pyramids.
It's hard to believe, but until recently, there was no proof that other planets exist outside our solar system. No telescope on Earth nor satellite in space was powerful enough to spot anything smaller than stars.
The reason is simple. Planets don't shine. They don't reflect very much light from their host star. They're dark specks of dust, if you will, floating around the universe, and people understood you probably could never detect them.
Marcy refused to accept that. Risking professional ridicule, he was determined to find a way to spot far-off worlds. Eventually, he found one. It turns out that while planets may hide from our eyes, they can't hide from the stars they orbit, what astronomers call their host stars.
Well, finding planets is actually very simple. We watch the host star, represented by my head, as the planet, represented by the tennis ball, orbits that star and pulls gravitationally on the star. As it does so, the star, my head, wobbles around, being pulled by the planet, and back on Earth, our telescopes can watch to see the wobble of the host star as the planet goes around it. Even if you don't see the planet, you can see the star wobble around. It's difficult to see it directly, but we use the Doppler shift of the star's light. As the star comes at you, the light waves emitted toward the Earth get compressed. And as the star goes away from you, the light waves get stretched out in their travels to the Earth. And so you can see the light waves compressing and stretching and compressing and stretching, which to our human eyes means the color changes. We see the colors change from bluer to redder to bluer to redder, and we can measure that at the back end of a telescope. This effect is well known, the Doppler effect, with sound. You can hear the pitch of a train whistle change as the train goes by you. Even with your eyes closed, you can tell whether the train is a-coming or a-going, and so it is with light waves from a star. You can tell whether the star is a-coming or a-going from the changing pitch of the light waves.
For nearly a decade, the Doppler shift method of planet hunting was an experiment with no positive results. Marcy still couldn't prove that planets exist outside our solar system, but he slowly won a few astronomers over to his way of thinking. He was no longer the sole detective on the investigation. In 1995, his patience was rewarded. A group of Swiss astronomers had their eyes on a bright object in the Pegasus constellation called 51 Pegasi b. The Swiss suspected they had found what everyone was looking for: a very large planet, the first one seen outside of our solar system. But they needed confirmation.
Luckily, my student Paul Butler and I had telescope time assigned to us just a week later on the Lick Observatory 3-meter telescope, 4 consecutive nights, and as luck would have it, the supposed orbital period of this planet around 51 Peg was 4 days. Perfect match. We went to the telescope, all 4 nights were clear, we measured the Doppler shift of 51 Peg, and we drove off the mountain 100% convinced that the Swiss had been correct. It was a marvelous moment, and the world was introduced at that time, in mid-October 95, to the notion that our solar system was not alone.
The discovery of 51 Pegasi b changed the entire game. The Doppler shift method of planet detection was proven successful, and soon Marcy and his colleagues found more and more alien worlds. They have slowly confirmed nearly 450. There are likely billions more. But Marcy's goal hasn't changed. He wants to find worlds like Earth that orbit in the habitable zones around their host stars, the comfortable place where it's not too hot and not too cold. Worlds that could possibly support some form of life. Planets in this habitable zone may have a key ingredient for life as we know it.
If you took any organism on Earth and you took out the water, you'd end up with some powdered amino acids, proteins, nucleic acids, a few fats, these sorts of things. But they don't work in a powdered form. You don't get the chemistry that would make life. So you need some kind of liquid, some kind of solvent to dissolve all these chemicals in. What all life on Earth uses as its solvent is water, liquid water. And so that is what we look for as a first step to looking for life elsewhere, the presence of liquid water.
But finding habitable planets isn't easy. Planets like Earth are small, and their host stars shine billions of times brighter. So they're hard to see. Looking for solar wobbles isn't easy either.
Now imagine a smaller planet. My head still represents the host star, and as this small planet orbits the star, it has so little mass, it hardly yanks gravitationally on my head, the host star, at all, making the detection of small, Earth-sized planets very difficult.
Marcy has gone from crazy outsider to the peak of his profession without changing his position. He doesn't back down in the face of a challenge. He plans to keep combing the cosmos a section at a time, looking for stars similar to our sun, and enjoying the fruits of our ever-evolving technology.
Here we are, about to answer a question that the ancient Greeks asked and humans undoubtedly asked even before then. It's a treasure of a moment in human history that we suddenly have at our fingertips, the telescopes, the computers, the light detectors, and the knowledge to answer a philosophical question that humans have been asking since antiquity.
The answer to that question, are we alone, may come sooner than we think. Because for the first time ever, we have an undercover detective not tied to the Earth, but floating in the heavens. A special agent in space specifically designed to track down E.T. in its native habitat. As a youngster, I read a lot of science fiction, which opened my mind to the possibility of life on other worlds. Until recently, we humans could only guess about this. But today, we live in a scientific renaissance. A golden age of technology where fictional possibilities give way to extraordinary discoveries. Thanks to our high-tech tools, we may be on the verge of solving the mystery of alien life. For instance, until recently, the investigators tracking down E.T. had to search from down here on Earth. But now, we finally have a detective in outer space. On March 6, 2009, NASA launched the Kepler Space Telescope. Kepler is the first ever satellite solely devoted to the hunt for planets outside our solar system. The hope is that Kepler will not just find more planets, but will discover planets roughly similar in size and atmosphere to Earth. Such planets could support life. William Borucki is the principal investigator for the Kepler mission. He's been planning this for 25 years.
Ever since I was a little boy, I was interested in space exploration. We used to lie on a garage roof during meteor showers and use cameras to take pictures of meteors. So it's a dream come true to work with NASA and actually be able to come up with a mission that will help us understand what might be out in space.
The beauty of Kepler is its simplicity. It looks for planets by measuring how much light a planet blocks when it passes in front of its sun. This is called a transit. A familiar example occurs during a lunar or solar eclipse, when sunlight is blocked by the moon or Earth's shadow. This is easy for us to see with the naked eye. But finding an Earth-like planet transiting a distant star is much more difficult.
An Earth-sized transit's really, really tiny. So it's like watching a flea crossing a car headlight at a really long distance, and you find that, and you measure it accurately.
Kepler measures these minute changes in light. Tiny differences between light and dark tells it where the planets are.
So what you see is some curve showing light being constant, a dip, the planet goes across and it comes back up again. So you're looking for that dip in light for each star when a planet goes across. And the bigger the planet, the more light it blocks, the bigger the dip. And so we can tell the size of the planet from the size of the dip.
But it isn't practical to observe one star at a time. Borucki had to find a way to look at many stars together. An unprecedented, some said impossible goal.
We had to show that we can measure the brightness of these stars, 100,000 of them simultaneously. It was met with a great deal of skepticism. And the science community actually published an article saying that can't be done. And so it took us quite a while to show that, yes, you can do that. You can build a wide field of view telescope with a huge number of pixels that measure all these stars simultaneously. And then you can watch each and every individual star to see if a planet is crossing it.
Kepler does this with amazing accuracy.
Basically, it's a huge camera that orbits in space. It does not orbit the Earth. It orbits the sun. And so I can look at one group of stars between the Cygnus constellation and the constellation of Lyra, 150,000 stars simultaneously, and make a measurement of each of those every 6 seconds.
Once Kepler detects a planet, the planet's orbital size can be calculated, along with its mass and surface temperature. As a member of the Kepler Science Working Group, Jeff Marcy believes that Kepler is the next great step toward finding life on other planets.
I think in the next few years we will find the first planets of Earth size, Earth mass, maybe even Earth-like temperatures, rendering them habitable. And I think it's fair to say that one of the great goals of the next decade or two is to build a terrestrial planet finder that can actually take pictures of other Earths and ascertain whether there's any habitability possible on that planet and indeed life there as well.
The payoff is just the pure knowledge of are there Earths, lots of Earths out there. If there are, there's probably a lot of life out there. If the opposite occurs, we don't find any, there never will be a Star Trek. There's no place to go to.
Better technology is getting us closer to finding those other Earths. For instance, by fine-tuning our sensors, we can now read the light reflected off a planet's surface. This lets us determine the chemical composition of that planet's atmosphere. Now that we can analyze atmospheres, we can start looking for the unique environmental signatures of alien civilizations.
Every form of technology leaves a footprint on its environment. For example, if you're looking at Earth from a long way away, you see global warming. That's our footprint. Well, we can imagine a civilization that might have been around for an immense period of time would leave a much bigger footprint, maybe not just on its planet, but on its entire astronomical environment. So we should look for anything out there in space, any anomaly, anything that looks like it could not have a natural explanation.
We're hunting for Earth-like planets and Earth-like life, and maybe, we hope, alien civilizations. But what if they aren't Earth-like at all? What if the aliens don't need things like bodies? Looking for life as we know it could be a mistake because, some say, life as we know it will soon be an artifact of the past.
I think it's entirely possible that we will discover microbial life on some extrasolar planet. But I think what people really want is they want aliens. They want somebody we can talk to, somebody that we can relate to as thinking individuals.
Will Wright is the creator of two revolutionary video games, The Sims and Spore. Wright designs software that creates alien life, creatures uniquely adapted to the myriad conditions that might be encountered out in the universe. Of course, it's all simulated inside his computer. Wright believes that life on Earth is radically changing. A new form of life is being created, part human, part machine.
You can almost look at any technology that we use today as an extension of the human body. The buildings are an extension of our skin. Cars are an extension of our legs. Telephone is an extension of our mouth. Humans have been so intertwined with technology for thousands of years already that it's really hard to almost pull the two apart. And that seems to just be increasing and accelerating over time.
Some believe that we might eventually get rid of our bodies completely and become creatures of pure consciousness, living in a giant computer. If this is slowly happening to the human race right now, has it already happened out in the stars?
It's probably likely that if we ever do meet intelligent alien life out there, I would imagine that there probably are going to be transbiological in some sense. They might be entirely mechanical civilization.
Physicist Paul Davies agrees.
In my view, biological intelligence is just a transitory phase in the evolution of intelligence in the universe. So after millions of years, you'd be dealing with something that might be distributed across the whole surface of a planet. It wouldn't be a living organism. It would be a sort of gigantic throbbing megabrain.
It's possible these alien super beings, whatever they may be, are sending us messages right now, but we aren't advanced enough to detect them. Then again, maybe that's for the best.
It could be that these alien intelligences have entirely different intentions, and therefore maybe they aren't broadcasting where they are. Or maybe it's a hostile universe. There are a lot of science fiction scenarios that go down the path of the ones that basically start calling out into the deep forest, or the ones that get eaten by the wolves. The intelligences that are out there trying to talk to everybody else are the ones that get eaten first. And that's why everybody else is being really quiet.
Maybe the aliens aren't friendly. On the other hand, they may not even think we're worth contacting, particularly if they're ancient, throbbing megabrains.
I think it's very unlikely that some super intellect that has been the product of millions of years of design is going to have very much interest in traveling around the universe. It would long ago have sent probes out and gather all the information it needed. I think it's much more likely that something that has been around for such a long period of time and has such enormous intellectual power is going to retreat into a sort of inner cyberspace. Probably lose interest with its immediate surroundings, so long as someone's paying the electricity bill and defending this throbbing megabrain from asteroid impacts and other dangers. I imagine that it's not going to be very mobile.
And there's another even bleaker possibility. What if there was other intelligent life in the universe, but now it's gone?
SETI's been going for about 50 years now, and all the astronomers have got to show for it is a silence, I would say an eerie silence, because many people feel that there should be intelligent life out there, there should be other civilizations, and if so, they're ominously quiet. Maybe the reason they're ominously quiet is because they've all died out. They've wiped themselves out, or some horrible fate has befallen them. If it is all silence, then that bodes ill for the future of humanity.
All of this leads back to where we started, with a simple question. Is there other life in the universe?
Absolutely. There must be other life forms in the universe, and I'm even willing to go the next step and say there must be intelligent technological life elsewhere in the universe. When you count up all the stars that are out there, those billions, trillions, even more Earth-like planets offer an enormous number of throws of the dice. Even if life is 1 in a million or 1 in a billion, there are just too many throws of the biological dice out there in the cosmos for us to be alone.
We have no evidence one way or the other for any life beyond Earth, let alone intelligent life. Therefore, my feeling about it is we wait and see. I've got to be skeptical until I get some evidence otherwise.
What's all the racket?
I would find it incomprehensible that the answer would be no. If it was no, that would be an amazing bit of information to have. I mean, even understanding how rare we are, you know, that maybe intelligent life, like we might understand it, is very, very far away from us, puts an incredible responsibility on us. All of a sudden, Earth, humans, directed intelligence becomes incredibly precious.
Our search for ET has been going on for half a century, but the universe is a very big place, and we've only just started to unravel its mysteries.
If you dip a glass in the ocean and you look at it and your glass has no fish, what's your conclusion? Is your conclusion that the ocean doesn't have any fish in it? Or is your conclusion that's an awfully big ocean and I didn't sample very much of it with my glass? 50 years of exploration of the cosmic oceans is minuscule. We haven't looked yet. We've hardly begun to search. We ought to do a much better job of searching before we draw any extraordinary conclusions.
The building blocks of life are spread all around the universe. It's hard to imagine they haven't taken root in one of the countless other planets out there. Is any of that life what we would consider intelligent? And if alien civilizations are out there, why are they so quiet? Maybe their signals are still on the way. Or maybe they use technology we don't understand. Or they may not be there at all. We just don't know. But one thing is certain. If we find life outside of Earth, it will profoundly change the way we look at life and ourselves. In the meantime, we have our hopes and dreams and the silence of the cosmos.